Hello students, in the previous video we have seen Mach number and the classification of fluid flow based on the Mach number. The next topic will be the finding or knowing out the nature of propagation of pressure waves or the sound waves or any disturbances in a compressible fluid. So we're going to see what is this nature, how the pressure waves are going to move or the disturbance are going to move inside a liquid, inside a fluid, based on the Mach number. That means the flow can be subsonic, it can be sonic, it can be supersonic. So how you actually going to describe the particular propagation or the movement of the pressure waves? The important things are like whenever there is a disturbance, the disturbance inside the fluid is going to propagate or going to move in all direction with the same velocity which is equivalent to the velocity of sound. The nature depends upon the Mach number. So if you consider a small projectile and this projectile is moving from left to right in a stationary fluid and the projectile is moving in a straight line. Okay, so as in this condition, this is a projectile which is moving from point A to point B. Okay, so we are considering it in order to understand the movement or the propagation of disturbance inside the compressible fluid. So when the projectile moves, the disturbance are created inside the fluid and the disturbance are going to move in all directions. That is, they are going to spread in a circular way with the velocity of c. Okay, so the velocity of pressure wave is nothing but the velocity of disturbance, or which is equivalent to the velocity of sound. So let me name it as capital C, and capital V be the velocity of the projectile. So based on the three different cases of fluid flow, based on the Mach number, we will try to find out how this particular disturbance move, or we need to graph it out. We need to put it in a pictorial representation. So let us take the first case where m is less than 1, where Mach number is less than 1. Mach number is v divided by c, so v by c is less than 1. The flow is subsonic in nature. Fine. So if v is less than 1, to find the nature, let us consider that v is 1. So v is less than c, right? So v by c should be less than 1. So if v is 1, let us consider that c is equal to 2, such that your v by c ratio will be half, which is less than 1. See, I can take any value of v by c which will lead me to the value which is less than 1. Here half, 1 and 2, so 1 by 2 will be 0.5, which is easier for calculation, so we are considering it. So let the projectile be at a point A. So if you consider it, just imagine a straight line here. The point A is the initial position and point B is the final position of the projectile. Projectile is moving from point A to point B. Okay, so you have four different points which are marked out here from 4, 3, 2 and 1. Okay, so these are position points. Okay, the position of the projectile after 1 second, 2 second, 3 second and 4 second along this straight line is mentioned as 4, 3, 2, 1. So after at 0 second the position is at A or 4. Okay, after 1 second the position will be at point 3. After 2 seconds the position will be at point 2. After uh, uh, after the fourth second the position will be at point 1. So from 4 to 1, this one, the movement will be happening around 4, from 1 second to the 4 second. Okay, the points are named to be as 3, 2, 1. Okay, it will come till here, and 1 to B will be the fourth second. Okay, so this is the 0th second position, 1 second position, 2 second position, 3 second position, and finally it attains at B, which is at the fourth second. Okay, it's all mere, what you can say, assumptions that we are going to lead, or we are going to get this particular picture. So now let us see The projectile is moving from A to B in 4 seconds. So the distance between A to B is 4 units, right? So distance, how you are going to get? You are going to get the distance with the velocity equation, where velocity is equal to distance divided by time. So distance will be velocity into time. Okay, velocity v I have taken it as 1. Okay, and the time is 4, so 4 into 1, it will be 4 units. The disturbance created at A in 4 seconds will move at a distance 4c, right? So the distance movement, okay, will be 4c. So 4 into 2 will be 8 units. Okay, so see, the whatever movement is happening from A, okay, which is at the 4th position, okay, C is going to be 2 over there, okay, and the time frame that we are thinking about is 4 seconds, so it is going to be in 4 seconds. Okay, the disturbance that is going to be created will be 4 into C. C tells us about the disturbance movement, so it will be 4C, okay, distance movement of the disturbances or the pressure wave. So they will move in 8 units. So from point A you draw a circle with the center at A, draw a 8 unit circle. Okay, if you are working in centimeter, draw a 8 centimeter circle. Now, taking the A as the center, you are drawing that circle, no problem. Now let us come to the point 3, which is at after what you can say 3 seconds, right? So the disturbance movement will be 3c over here, because you are at the position 3 over here, it is going to be 3c. Okay, the distance traveled by the projectile is going to be 3v, and the disturbance traveling distance will be 3c. So c is 2, v is 1. This will be 3 units. So from here till here the distance will be 3 units, no problem. So from point 3, with the center at the point 3, you need to draw a circle, and that circle value, okay, should have 6 units as its radius. Okay, with the radius as 6 units, you draw a circle. Similarly, repeat it for point 2, where it is 2c. So it is 2 into 2, 4 unit circle you have to draw. Okay, at point 1 it will be 2c, so it will be 2 into 2. I'm sorry, it will be 1 into 2 at point 1, so 2 unit circle you need to draw. At point B, okay, it's the last point, so no need to draw a circle over there. The important thing here that you have to note down is, see, as your capital V, that is the velocity of projectile, is less than the velocity of the sound wave or the disturbances, the pressure wave is always ahead of the projectile. See, if I see this particular point A, this is larger. Okay, when I start moving it, okay, this is ahead of that. See, the pressure wave of A is really ahead. Okay, at point 3, if I come and see, this particular circle is ahead. Okay, it is much ahead by this distance. You have to see at this distance after B. So the pressure wave is always ahead of projectile, and the point B is inside the sphere of the radius, the biggest what you can say circle. Okay, this point B, okay, it is inside. Now if you come to the second case, wherein the Mach number is 1, V and C both are equal, so I can take V equal to 1 and C equal to 1. This is the case of a sonic. So the way you solve is actually same. Okay, from A to B there are 4 units, so distance is 4, 4 into 1, so that's all things, 1 into 4 or 4 into 1 you can take. Okay, at point A it will be 4 centimeter, because V is equal to 1. Okay, and C is also 1. In the previous case C was 2. So to draw this pressure wave circle at point A, it will be 4 into 1. At point 3, okay, it will be 3 into 1. At point 2, it will be 2 into 1. At point 1, it will be 1 into 1. So the unit of these circles, you see, and if you just observe this diagram, all the circles, they are meeting at this particular point. Okay, so that is the importance when m is equal to 1 comes for the sonic flow. So the disturbance that is created here, they are all coinciding, right? That means, okay, the disturbance wave or the distance moved by the disturbance wave or the pressure wave and the projectile, it is same. Okay, there is no difference between them. But in the previous case, the projectile was very slow and the disturbance wave or the pressure wave was moving very fast. Now we will see the next case, that is the third case, where we are getting a cone called a Mach cone. This is very important criteria, or the third case is very important. So when m is greater than 1, okay, so what is going to happen is I have to take the value of c lesser than 1 or lesser than the value of v. So if I'm taking the value of v as 1 unit, I have to take the value of c lesser than that. So let me consider it as 0.5. So that your v by c is 1 divided by 0.5, so which is nothing but, this is the case of a supersonic flow. Now the movement, or the initial, what you can say, projectile movement, if it is happening in the 4 seconds, if I take it is 4 into 1, then the disturbance movement, okay, will be 4 into 0.5, okay, at point 4 or point A you can take. So if you see, it is 4 into 0.5, 2 units. That means I have to draw a circle which is equal to 2 units. I am drawing this outer circle over here with the center at point A or at point 4. Similarly, if I come at point 3, the circle value will be, okay, 3 into 0.5, which is 1.5, right, half of 3. So 1.5 centimeter or 1.5 unit circle. Similarly, half of 2, okay, 2 divided by 2 into c is 1 divided by 2 or 0.5, so 1 unit circle. At point 1, half of point 1, which is 0.5, so I will be drawing that. So 1 into c is 1 by 2 or 0.5, so 0.5 circle will come over here. When you join, okay, or when you draw a tangent, common tangent from point B, if I am drawing a tangent which is common to all circle, okay, on both the sides from B, I am going to get a cone, shape of a cone, which is called Mach cone. This is very important, what you can say, phenomenon. So in this particular case, the sphere of propagation of disturbance wave is always behind, okay, the projectile motion. The projectile is much faster. See the point B, it is outside the circle, right? So the disturbance wave is going slower compared to the projectile movement. So this is an important thing. Okay, if you draw the tangent, you are going to get a cone, and that cone is called a Mach cone. The vertex of this particular cone will be at the point B. Now if you concentrate here, I am drawing a 90-degree line from point 1, okay, towards the upper side, one of the sides of the cone. If I am drawing it and let that line meet at point D over here, okay, so Mach, I can define an angle called Mach angle, which is half of the cone angle or the Mach cone angle. So let me call that particular angle as angle alpha. Okay, this value alpha means a lot, okay, in the numerical problems which are going to solve. So consider that small triangle 1BD. Okay, this particular small triangle which I am showing here, 1BD, this triangle. Take the sine of alpha. The sine of alpha will be 1D divided by 1B. 1D is nothing but c, okay, which is nothing but the velocity of the sound wave, and 1B is nothing but v. So sine of alpha is 1 divided by v by c, which is m. So 1 over m is nothing but sine of alpha. That is your Mach angle. Something called zone of action, which is where m is greater than 1. Whenever the m is greater than 1, the effect of disturbance is felt only in the region inside the Mach cone. So outside the Mach cone, there is no pressure wave coming up. So inside that value only you are going to get the feel the disturbance. So that is called zone of action. Zone of silence is when m greater than 1, there is no effect of disturbance in the region outside the Mach cone. So that is the zone of silence. So in this particular diagram, if you go and see, okay, this is zone of action, and outside this particular cone, okay, the tangent line, whatever zone you find, this is the zone of silence. Okay. So with these topics, we are ending the propagation of waves, pressure waves. We will see the numerical problems in the next video. Thank you.